I don't think we're recording because look at my screen. Look at this. I can't teach. Oh my gosh. So here we go. Okay, I'm gonna see if this stop. Okay, I think it stopped. No, it's not stopping. Okay. Shh. Do you hear my 6 hour? This is actually all on tape. I'm going to try to fight through this, but look at my screen, and hopefully the video does this on YouTube. To prove the technology I deal with, the second-year computer, this is brand new this year. This didn't happen last year. This is why I don't make movies anymore. Last year there was different problems, but I'm going to try to fight through it because in class you can't see that flashing. But I think on YouTube you'll see that. Flash, flash, flash. All right, so anyway, going to continue. Where are you going? All right. Okay, so this says kind of 10.2. What this is a setup of concepts that you're supposed to know going into, the next couple things. Not maybe you're supposed to know now. Like, does anyone know what 6 factorial really means? Not many do, and I noticed that back in the day. But I think you did do the other things. It might be new in Math 2 or Math 3 that you did some more things like permutations and combinations. But the very first thing is, we got that flash. Have fun with that on YouTube. Okay? 6 factorial actually means 6 times 5 times 4 times 3 times 2 times 1 times 0. My computer is possessed. Anyone watching this? So this is what's going to tape. I'm going to keep going, and I'm going to put this on YouTube so you get to see, everyone gets to see in the world what I deal with this crazy computer. Brand new last year. It is worse than the computer I had in 2013. I'm putting that online for the world to hear. Okay, so what does n factorial mean? N factorial is n times n minus 1 times n minus 2 times n minus 3 forever. Keeping going down. There's that flash again, but... Okay? So 6 factorial is 6, 5, 4, 3, 2, 1 multiplied together. And you can type it on your calculator. I do have the calculator ready for you. Second quit. Just to show you where is the factorial button. Get out your graphing calculator that you're all supposed to have anyway. And then you hit math. Okay, and then it goes to, I'm getting confused because I got the flashing issues. It's with my ADD, I really can't, I'm going to keep fighting. Okay, I'm going to keep fighting. Okay, and then go over to probability. Math and then probability. Then these actually 3 things you're going to use. 2, 3, and 4. NPR, NCR. Anyone remember NPR, NCR? You've done it. I think they do it now in the Math 2 or Math 3. It's not stopping. And then, so what do you do for that? You do 6 factorial. You type it just as it looks. You write the 6 first, then the factorial. Oh my gosh, people that are watching this online will have a headache. Yeah, how about it? And I don't know. I'm just going to continue because I feel like I have to have a video. Okay, now, this is wild. This is wild. What's 0 factorial? What do you think 0 factorial would actually be? 0. Okay? It actually is not 0, which is what it should be. It's just like 0. It's actually 1, and the only reason is, and if you type it on your calculator, go ahead. Type 0 factorial. It'll spit out 1 at you. It's only because to make a later formula actually works. So, and you'll see that coming up shortly if you can just be patient. So it is a weird anomaly, all right, that we need to know. Do not write this next part. This is from yesterday. But now we're going to turn this into factorial language. But this is what I would share with my CAT students when we did Chapter 9. All right, how many different ways can you arrange A, B, C? Or let's pretend you put 3 letters in a bag, A, B, and C. How many different ways could you pull those letters out? Well, I could pull A out first, then B, then C, or A, C, then B, Or I could get B first, then it, blah, 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 blah. This is doing a tree to see how many different ways this could happen. When really what it is over here, I have 3 letters to choose from first. I pick one, and then I choose a second letter, and then I choose a third letter, but I only have 2 to choose from and then 1 at the end. Now we could say that's 3 factorial with our new language, right? So I have 3 letters. How many different ways can I choose those 3 letters? 3 times 2 times 1, 3 factorial. So that was the only point of that, where factorials come into play. Oh, geez. Hold on. I'm having a struggle here. Go ahead, what? If I don't replace. Yes, no replacement. So if it was replacement, it would be 333. Yeah. Good call from yesterday. Okay, with or without replacement. All right, so all this says, don't write this down, don't write this down, don't write it down. Why do you do this then, Mr. S? If someone wanted to open up the notes that were absent and were readers, all this does explain that yet again. All right. Okay. I'm gonna persevere. And then just go ahead and take a look at this video tonight and see if this actually happens. Okay? Like you said, you might have a seizure. All right. I don't think so, because it is literally recording my screen. But I'll be amazed if it's not. I'll be amazed. So we'll see. What's he talking about? He's a lunatic. All right. That's probably true. So Tennessee license plate consists of 3 letters followed by 3 numerical digits, 0 through 9. First of all, how many numbers are between 0 and 9? It's actually 10. Good. It's not 9. So just to get through this so I don't have a seizure myself. How many letters are there in the alphabet? I think last year's didn't know that. Okay, so 26, and then you have 26, and then does this have anything to do with factorials right now? No. Shh. Too many side conversations. Let's just get through this. No, this is not dealing with factorials. And the worksheet that I should have given you when you walked in, which unfortunately I do have right here that I got to give you. Not all the questions are factorials. Not a lot of them are permutations or combinations. Some of them are just fill in the blanks by thinking. I have 26 letters I could put in the first position, and it says no restrictions, so I can put 26 letters in the second place. I could have AAA 111 as a license plate. Or I could have ZZZ, 999. I forgot about 00. And then how many digits are there? 10. And if you didn't know that, 0 is the first digit. Count it with your fingers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 digits, not 9. That's a common mistake that we get for that. Now, I don't know if this is true anymore. This book for CAT we got in 2009. I'm sure Tennessee has something a little different now. We have 7 possibilities on our license plates in Illinois. But even with this, Tennessee could create 17,576,000 different license plates. That may or may not be enough for Tennessee, though, so I'm sure there's something different. I doubt that's enough for Illinois, not even close. So that's why Illinois has 7 spots, and I think all of them could be digits or numbers. So if that were the case, it'd be 36 times 36 times 36 times 36, blah, 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 which would be a huge amount of possible license plates, right? Make sense? Because if I could have a digit or a number, I have 36 possibilities for each one. All right, and then this is just for, stupid, are they reading kind of thing. No letter or digit could be repeated. And again, I'm not going to bother you, for calling on you. Oh my gosh, I can't hit that when it's flashing on me. 26, but then if I can't repeat, what would be the next possibility?
25.
And then the next possibility. And then the digits. 10, and then what?
9.
And then what? 8. Do you hear it? Wow, the class. Hopefully you can hear that online. If you're still watching this, unless you're passed out on the floor from a major incident. I'm still surviving, though. Somehow I am. And you're right. What if this doesn't show up on YouTube? What's this clown talking about? Which will be even funnier. All right. Okay. Don't write this down. I didn't write anything down yet. All right. So permutations. Permutations. This is all you have to put for this is, and again, why did I cut all this from the cat book back in the day for kids that wanted to read? Here's minimally what you should write. Permutations are when order is important, and then just leave it at that. Order matters. Okay, and then in the first one, it can be related to the permutation formula. You saw it on your calculator, those that recognize it. It was the NPR button on the calculator that you saw here. But this is a little different. And I know for a fact that you had these kind of questions in either Math 2 or Math 3. I was a tutor last year, and I saw a Math 3 student every day, and a couple Math 2 students would come all the time, and I forgot which worksheets had this. This whole weird thing about, all right, now listen, all three of these are 9-letter words, so they want count the number of different 9-letter words, parentheses, don't worry about whether they're in the dictionary, that can be formed using the letters in each word. The first one is straightforward, and actually can be done just like the license plate question. Well, no, just like the question at the very beginning with the ABC. Because what you could say is this. First of all, are there any repeating letters? Okay, we'll get to that later, how that changes things. So how many letters do you have in the first choice, like to start a word? And then after you choose that letter, how many letters do you have after that? And then how many letters after that? And then how many? And then 4, 3. What is this actually called? 9 factorial. Now do understand, I have 9 letters, and I want all the different 9-letter words I can choose or make. So I am choosing all 9 letters to make new words, even though they may not be sensical words or words in the dictionary. So this is the same as 9 factorial, which would be 362,880, flash, 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 flash. So I'm trying to not look over here. I'm going to be cross-eyed at the end of this. Okay, and then butterfly and bumblebee. What's the problem with this? Listen. Okay, and this actually turns into, and then how is that a permutation? I'll get to the permutation formula later, and only dragonfly can be compared to a permutation. Butterfly is a problem. Listen. Okay, this is one of the 362,880 words, because isn't there still 9 letters in butterfly? Yes. Don't have to count it, trust me. But what if I switch the T's? Is that still butterfly? Is that distinguishable, or is that the same? The same. So are there 362,880 different words I can make with butterfly's letters? Yes or no? Actually, no, because even the word butterfly, I could do it 2 ways, and it's the same word. Do you get it? So how many do you think there are with butterfly? What would I have to do with this 362,000 number? Not subtract, divide. Because for every word that I make, I can make it 2 ways with the T's being switched that are not different. But it's even more than that. You're supposed to divide by 2 factorial. What? Calm down. What's 2 factorial still? It's still 2. And I'll show you why it's 2 factorial because of the next one. They're laughing because you can see, and I'm not looking. Okay? Do you got it? So it actually is half of the amount of words that, and you could calculate that. I'm busy. It takes too long. I'm busy not having a stroke up here. Okay, and then now let's look at bumblebee. And I actually did this with the other hours. First of all, we got a problem with the B's and the E's. And I did this a few times just to demonstrate a concept. Bumblebee is one of the 360,000 words. But couldn't I switch those B's and it'd be the same word? Yeah. Right? How many different ways can I switch those B's? Anyone know the answer to that? Well, I could write B3 first. This is why I'm not writing this. I don't have the, and then B2 second. and B1 first. As I'm writing this, does anyone know how many different ways I can write bumblebee just by switching the B's around? It's not 9. It is 6. You are right. I'll just do one more, and then and you can keep going on this. Switching the B's, when I put those little subscripts on it, then it's just denoting that I rearranged the B's. The problem is you're counting those 3 B's as different by just doing 9 factorial. Oh, yeah, that should be a 3. You're right. And so on and so on and so forth. So, and then what about the E's? There's 3 of those. How many different ways can I rearrange the E's each time? It's actually 6. Do you know where 6 comes from? 3 factorial. There is 3 factorial ways of rearranging the B's and getting the same word. And there's 3 factorial ways of switching the E's and getting the same word. So it's not distinguishable. So therefore, we need to divide it out to figure out what words are distinguishable or different. Did they use the word distinguishable? No, there we go. Distinguishable permutations. Dun, dun, dun. And then you can calculate that, making sure you put both 3 factorials on the bottom. So I wanted to show where 6 came from for those that got that right. How many different ways can I rearrange the B's and still get the same word? Well, it comes from 3 B's factorial. 3 factorial. 3 E's factorial. Blah, 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 blah. Only this can be called the classic permutation. I'll show you the permutation formula, then I'll go back and show you how this is a permutation. And here it is. Go ahead and write this down. So your job today is to memorize this formula. I'm going to be a meanie. I'm going to actually make this a no calculator. You will have to memorize this. How? Maybe I'll be nice and put the formula there real quick. I forget. I don't know. Be ready for either. This is an honors class. Dun, dun, dun. Okay, and then this is the calculator button. But I'm not going to let you touch the calculator. Don't freak out. Okay, and then, shorthand the notes. Permutation. Remember, permutation means order important. Formula. All this says is R is, smaller than N, at least, or maybe equal. And you can only deal with positive numbers with permutations. You will never see negative 2p negative 1. It doesn't work. This is a counting principle, so you're only dealing with natural numbers. These are counting principles. How many ways can something happen is what this whole probability is all about. So you're only dealing with positives. So that's all that's saying. When I write, it stops flashing. It's so weird. You can see it, can't you? Okay, and then, how is dragonfly still a permutation? Please listen, because I had a good questions first hour, but they're not quite listening. We had 9 letters, and we wanted to know how to arrange those 9 letters 9 different ways. That's the second number. It didn't have to be that. We could have said, let's take that dragonfly letters, those letters, and try to find out how many 5-letter words out of those 9. How many different ones? That would be 9p5. Did you hear me? But because it said 9, I have 9 letters, permutate all 9 of them, it's a 9p9. And then look at the formula compared to what we had for dragonfly. And only dragonfly, because there was no repeating letters. It can be considered a 9p9, and the formula says it's 9 factorial over 9 minus 9. And remember what we said? What does 0 factorial have to be? Well, it has to be 1 so the permutation formula works. And there you go. There's no other reason for it. Bless you, my child. She's not. She goes, you're not my father.
Hi, YouTube.
Oh, no. What just happened? I hit the wrong thing. Oh, man. Did I just end the video? What's going on?
Oh, no.
Oh, here it is. Okay, we're back on. And it's back flashing. Okay. I can't wait to see if this actually shows up on YouTube. I really think it's gonna. All right, but I'm a little nervous it's not showing here. I'm surprised it's here but not there. I don't get that. Okay, so here we go. The other hours I asked people. We're doing a video, so at least you get the. Okay, so I'm gonna tell you how I'm gonna be mean. First of all, this is oh boy, boom. Okay, I can work. When I start writing, it stops. In the numerator, it's 6 factorial. I'm going to tell you why this is a no calculator scenario. Don't freak out. Okay, if the numbers are large, I'll expect the answer to be written like what numbers are left over when you multiply. So simplified. So right, from our permutation formula, it's 6 factorial over 6 minus 4 factorial. Correct? Nice, cha-ching. Awesome. I'm like a gangster here, and then I have teachers pay me off every once in a while. Or else, did you see that? Did you see that? It's just dropped. I'm just kidding. Just a joke on YouTube. I forgot I was being taped. A teacher just came in and dropped money on my desk. I don't know what just happened. Okay, so 6 factorial is 6 times 5 times 4 times 3. You will never do this again. Over, what's 6 minus 4? 2 factorial, which is 2 times 1. You will never write this all out. You're going to find out something about this. But by the way, who cancels? Not the 6, the 2, and the 1. So in the future, I could have just wrote 2 factorial over 2 factorial, and the 2 factorials would cancel, wouldn't they? Just like the 2 and the 1? Just hold that thought. All right. Would this be the final answer? Oh, I think a senior should be able to get that number. So I think they should be able to do 6 times 5, which is 30. 4 times 3 is 12. And then reasonably be able to multiply 30 times 12. I don't think that's out of the realm of what you are able to do. My Sammy Samuelus in 5th grade last year had to change 6,626 and 2/3 into an improper fraction by multiplying 3 times 6,626 and then add 2 and then put. Do you understand what I'm saying? Okay, so I think I can ask a senior to get 360 out of this. Did I say good afternoon, by the way? I feel like I'm getting a little. Next. Isn't this, I'm walking around making sure everyone's taking notes. Here we go. Isn't this 11 factorial over 11 minus 3 factorial by the definition of the permutation? NPR, n factorial over n minus r factorial. Yes, it is. Now, this is what we're not going to do. We're not going to do what we did in the last one. And this should be understood. As a senior sitting in here having good math abilities to get this high in this class. Get this this level of class. Stop and write 8 factorial. Don't write 8 times 7 times 6 times 5 times 4, 3, 2, 1. Because on the bottom, what's 11 minus 3? 8 times 7. What would happen times 8 what would happen to 8 times 7 times 6, 5, 4, 3, 2, 1? They would cancel, so stop there and cancel those. And I can't help someone that says I don't get it. The 8s cancel, the 7s cancel, the 6s cancel, the 5s cancel. How come you can't figure out the 8 factorials cancel? So therefore, what's left over? 11 times 10 times 9. Is that large? Okay. On the quiz, there may be a lot of numbers left over. So you're just going to cancel, and then you can write that out. All right, but I think as seniors, we could probably all multiply that out and get the answer. What is it? And then this last one is just to be cryptic. What is NP3? Well, at least the numerator is waiting. N factorial over formula just says. But you know what? I'd mark it wrong. Because actually you can simplify this. What is n factorial? It is n times, what's the next thing? What does it go down by? No, what does it go down by? So it's n minus 1, right? Doesn't each number next go down by 1? And then what's the next one? N minus 2. And we could do this forever, except for the fact the denominator is n minus 3 factorial. And what's that? It's n minus 3, n minus 4, n minus 5, n minus 6, forever. And what happens forever is those things forever cancel. Right? So what's the final reduced answer? This is n times n minus 1 times n minus 2 simplified. And what this says is anything P3, like 72 P3, would be 72 times 71 times 70. Did you just hear that? Okay? So that's what it says. It's like writing a formula out of that. Remember, permutations are when, what's this word or these words right here? What's taking so long? Now we're getting a big delay. Maybe I went in a little dead spot in the room. Because this is how much, see how much I've circled so far? Oh, there it is. Okay. This is why my class wasn't responding. You didn't see this in this. It took like a minute to show up on my overhead screen. There's a lot of fun computer stuff going on right now. So I say again, permutations are when order matters. Okay, so look at this next question. This is like what I said about the words. Dragonfly, 9 permutations, 9 at a time. What if I only wanted 5-letter words? It'd be 9P5. 10 people run a race. How many different ways can first, second, and third place be awarded? Why does order matter? Do you want first or do you want second? You want first. It's a bigger prize. Okay? Second is different, and so is third. They're all different. So order matters. You have to, as a student, decide, does order matter in these questions that are asked like this? So it is a 10P3, and then that one you can do on your calculator, just get the answer. Okay, how do you do that? Real quick, go to your calculator. I'm already there, so I can go down when I get a flash. Okay, and then enter, and then I can type 10P3. By the way, the first number always has to be the biggest. From 10 people, how many different ways can we finish first, second, and third? 3 different ways. If you put 3P10, the calculator is going to destroy you. Hey, that's weird. 720 different ways. Weird that that's the same as 6 factorial. Just a random thing. If you have an older calculator, you have to type 10 first, then access the NPR button, then type 3 second. So just make sure you're at your desk, you're figuring out, can you do that? All right, this is where it gets a little wishy-washy. And again, we have different questions. You have to understand in your worksheet. Some of them are fill in the blanks. License plates. Just put 7. If it's 7 numbers, put 7 things. 4 of them can be letters. 3 of them can be numbers. That's not a permutation or a combination. That's 26 times 26 times 26. Got it? But then when they have questions like this, like the last one, you have a race, 10 people, 3 people finish. How can they finish differently? It's a permutation. And then this could be argued, but I don't think it can really. It's close. Anyone that's in a play, you try out for a part and you don't get it, but you get another part. You made the play, but isn't that different? You have to play a different role and it's a different thing, and you may be disappointed. You may have wanted like Sneezy instead of Scrappy or whatever the dwarfs are. So wouldn't you agree that if I had 16 actors trying out for 7 roles, how many different ways can that be assigned? It's a 16P7 because whatever role you get, it's different. Right? And then I'll really try to figure, when we do combinations, you'll see a real big difference between these two. Okay? And I'll try to explain it, but really the crux of it is, it's a permutation if order matters how things are picked. It's a combination if order doesn't matter and how it's picked. And I'll try to explain it, though, to get you to understand it further, because that's what I feel like my role should be. When you walk out of here with a more firm understanding, then it's remembered and it's locked in. Now look at the combination formula. Again, just put combination, put order doesn't matter, and put the formula down. All this denotes is all the math that has to be taken care of. All these numbers are greater than 0. N could be equal to R. N needs to be greater than R. Who cares? Okay? So really all you have to do is write the formula and maybe write my little note to self. Notice the difference in the formula is what I've highlighted in yellow. Let me get rid of that yellow I highlighted here. And then notice the added feature. It's not just n factorial over n minus r factorial. It's r factorial times n minus r on the bottom. And what that r factorial is related to the repeating letters concept in a way. Because what that does is takes the repetition out of a scenario where order doesn't matter. Bumblebee, when I switch the order of those bees, it doesn't matter because it ends up being the same word. So in a combination, it doesn't matter in order when you use it. So what that does is take things that make order matter. So that r factorial takes that situation out of it. And I'll make that a better explanation when we talk about Mrs. Krabappel in our next example. Son of a nutcracker, I keep hitting the wrong thing. Cared. Okay. So, I didn't say anything about what she's doing, but let's say Mrs. Krabappel chooses 5 people from 20 students to go on a field trip with her. Does it matter if you get chosen, whichever is right? I don't think any of them are. If you get picked first or 5th? Yes or no? Here's the problem if you make this a permutation. You put in the fact, say you 5 right here get picked. Is she okay right there? Oh, we got her. Nice. Awesome. I just saved a student from sleeping and drooling on my desk, and I have to clean it up later. So let's take these 5. So if I pick these 5, does it matter if she's first, second, third, fourth, fifth, or first, second, third, fourth, fifth? Does it matter? No. If you permutate that, you make it matter. And it's part of the situation when it doesn't matter. So what this is a combination because it doesn't matter if you get picked first, second, or third. And what it does is take out all those different ways those 5 individuals could get picked because it's throwing the order mattering in that scenario. We need it out of there. So what ends up happening is there's 5 factorial ways each 5 people could be picked to go on that field trip. We're getting it out of there because those don't matter. Those are not different. They all end up going on the field trip no matter what. If you don't understand what I just said there, it doesn't matter. If you do, you have a higher level of understanding what's going on here. Your job is to say this. If the scenario order doesn't matter, pick a combination. If the order matters in the cereal, I'm hungry. Pick a permutation. Fumble. Okay, so now it's the permutation combination game. You don't have to write this down. Another fumble. It's a fumbleitis. What is it? A permutation or a combination? I'll read it so we can finish this off. How many different ways from 25 people, well, can I pick, just go ahead, can I pick a president, vice president, and secretary? Does order matter, yes or no? Because president's different than vice presidents. Don't mention the president, we hate him. All right, so order matters, permutation. A cook chooses 5 potatoes from a bag of 12 potatoes to cook and make potato salad. Does order matter how he picks those potatoes? That's a 12C5. Order doesn't matter. Those potatoes are cooked no matter what. Teacher makes a seating chart for 22 students in a room of 30 desks. Think about a seating chart. When I give the seating chart to the sub, does it matter what seat you're sitting in? Does order matter then? I changed the order. You're in a different seating chart. This matters. This would be a 30P22. That's a permutation. We have a pause. Is the lottery. How many people have heard of Illinois Lotto? Okay, and then Mega Millions, Powerball. I looked these up online today. It's so interesting to me that I remember Lotto as a kid when my mom and dad would buy it. The first Lotto was only 40 numbers, and you pick 6. Now the Lotto I looked up online is 52 numbers, pick 6. Does order matter? It actually doesn't. Okay, it used to be that the balls would come down and fall and roll, and then it would go like 25, 13, 12, 1, 3, 6. Then at the end, they put them in order. 1, 3, 6, 12. I'd be amazed if I remember all the numbers I said. 13, 25. I think I did. All right? And then that's how you picked them on the card. So for Lotto, does the order matter? No. So for Lotto, it's a 52 number draw from, and you combination with 6 numbers picked because order doesn't matter. And then when we go to our calculator, we're going to calculate all of these. Clear? This is how you do it old school. 52. Did someone just throw something at someone else? I could see that out of the corner of my eye. I saw you. That group of 3 over there. 3 hooligans. Okay, now listen. That is 20,358 different numbers. Do you know what this means? I could cover every number in Illinois Lotto. There are 20,358,520 different number combinations. But what does the Illinois Lotto pay? Right now, I looked it up today. It was $12 million. It would cost me $20 million, $20,300,000, because it's $1 a ticket, $1 a number, to cover every number, but you guarantee that you'd win the lottery. Interesting? Okay, and then Mega Millions. What's funny is these were my old notes from 5 years ago, and Mega Millions only had, this is a big difference though. What they had is they separated 2 sets of numbers. They have what's called the Mega Ball. You ever hear about that? Or the Powerball? So Mega Millions and Powerball has 5 numbers first to choose from, then a Mega or Powerball. And that changes the odds and changes the amount of ways this can happen significantly. And Mega Millions even got worse. It used to be 52 numbers to choose out of the first 5, and then 1 Powerball. I think it was out of 52 numbers again. And I actually typed this in my calculator back in the day, and it was 175 million different possible combinations of numbers. Order not mattering. If order mattered, it'd be even worse. It'd be way worse. But now I looked up today and bought 12 tickets, because if I win, I'm out of here. All right, sorry. 70, was it, what did I say? I just lost my concentration. I was thinking about Hawaii. All right, where did it's flashing. 70 math. It's so easy, isn't it? There's actually another way with these calculators to get this. You choose 5 from the first pool of numbers, and then only 25 numbers for the Mega Ball. So out of those 25, isn't that what it said, 25? Because I looked this up. I better hit the, I'm a little worried what's going to happen mathematically when because this new convoluted calculator, sorry that you have to watch this. Oh, son of a, that wasn't even good at all. Okay, I know what I got to do now. This is great. Hey, just keep watching, YouTube. Delete. What? Okay, let's move over. This is stunning video. This will make video of the year. 1 million hits. All right. 25 math probability. Hallelujah. Choose 1 Mega Ball. Watch this. Press enter. Boom shakalaka. That, if you put the commas here, there is 302 million different combinations of numbers, blah, 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 all those other stuff. Do you ever hear Mega Ball worth $500-600 million? Raise your hand. Yes, right? So conceivably, I could buy every single number that exists because it's $1 a number. I think Mega Millions might be $2, but let's pretend it's 1 per number. You could buy for $302 million, blah, 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 every single number and guarantee your win of $600 million. What's wrong with that philosophy? Number one, who gets over half of your money? The government. And number two, what if there's another winner? What do you have to do? Split. So it's actually really bad anyway. But I just wanted to share that. There's only 302 million possible. So what are your odds when you buy 1 million, one ticket for Mega Millions? What is your probability of winning? 1 out of 302,575,350. I always like ending this with Mega Millions and Illinois Lotto so that you know what your chances are of actually winning those scenarios.